Well, welcome to the um, March is the March
March 10th.
10th, 2025 or 26 session uh, um, Tapper and HamSCI technical session. My name is Dave, KD0S, and this week I've been going back working on um, rebuilding some unique config files for my area on K9Q radios. So um, I had a bunch of these, and over time, I've misplaced them or lost them. So I'm slowly rebuilding many of the ones that I used to have. So that's it for me. Next on the list is Nathaniel, W2NAF. Go ahead.
Thanks, Steve. I have been working, keeping all of the different projects going over here with many different students and collaborators. And we're getting ready for the HamSci workshop, which is this weekend already. Unbelievable.
Nice.
So I'll be heading up to the ARRL on Friday, and we're getting ready for it. Back to net.
Okay. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Oh, just the same old from me. Um, Mucking about, trying to make things more, mostly make my environment a little more coherent. Um, Installing tail scale so I have a better backdoor into my home stuff when I go to HamSci. Some other kind of machine language things, but right now, but otherwise not too much and not much that's very interesting to this group. That's it.
Okay. Next on the list, we have Phil Karn, K9Q. Go ahead.
Hey guys, not too much to report this week. I will be at HamSci this weekend. I'm going to fly in on Thursday, actually, try to give me an extra day to resync, which is always a challenge in flying east. But I will be there and looking forward to seeing everybody.
Very good. Next on the list, uh, well, we'll let Rob have his time a little later. So next is Dave H, W6OQ. Go ahead.
Yeah, good evening, everyone. Just doing the usual thing here, hanging out, see what I can learn. Thanks.
Okay. And then next on the list is Dave, WB9YIG. Go ahead.
Good evening, folks. Not much going on here. Just worked on my weather station and stuff and relocating the wind speed, but got it done, and that's all. Back to the net. Thanks.
Okay. And next on the list, we have Dave McGaw in one HAC. Go ahead.
Good evening, everyone. Getting ready for the workshop, putting final touches on my presentation, um, working on our ground station. Uh, we're kind of down on the commanding our CubeSat because for some reason they need, Montana is our primary ground station. They need a kilowatt level 70 centimeter amplifier to talk to it. We don't have that here, so I've put out an APB, a request to see if anyone has one around here. But otherwise, our spacecraft seems to be alive, but it likes to be talked to periodically, so it's reset itself. And I guess that's about it, except spring has sprung here, except it feels like summer. It's in the 50s and 60s all of a sudden. And the snow is melting away very rapidly, um, making it easier to get to antennas and things like that, I guess. So, anyway, back to net.
Yes, we've been in 50s and 60s, and today we had an 80-degree day here in Missouri. So,
Yikes.
84.
and
I
they
think.
predict 80 tomorrow. So then it goes back to something more normal.
Oh, and one last thing. I wish they'd stop putting us on daylight savings time.
Oh,
Leave the clocks alone.
Move to Arizona.
Well, there's
yeah,
that.
that's an idea.
Hawaii, I
Okay.
think.
Yeah. So next on the list we have Clint K7 OEI. Go ahead, Clint.
Okay. Yeah, just still not doing a whole lot of radio projects. The only thing that I really did was I stuck a 4-tune loop of wire around my WWVB clocks on the wall and did a little amplifier. So now they work again. I moved my Kiwi and some network gear near them, and they about a year ago, and they haven't updated reliably since. But now they update. I was reminded of it when none of them updated for daylight saving time. So um, that's sort of a radio thing, but I guess it's better than nothing. So back to you.
Okay. Next on the list is Gary AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just thought I would check in case there's any last minute issues or questions having to do with the workshop. People are submitting their posters. We got quite a few of them in. People submitting their talks and whatnot, so we're going along in good fashion. That's it. Back to you, Dave.
Very good. Next on the list is Jonathan KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been the majority of my free time has been preparing for the workshop. Nathaniel, I have two quick questions. The first is I wanted to invite a Anirban to the workshop virtually, and I was wondering if I could I can do that. And then secondly, I also wanted to possibly invite Paul's wife Deborah. She might not accept, but if she does, um, uh, I was wondering which opening talk that the plan was to mention the workshop dedication, and then I could give that to Deborah so she could watch at that time. Those are the two questions. Other than that, I've been very busy with preparation. That's all I have. Back to the net.
Okay. Go ahead,
Sure, Jonathan. Yeah, really
Nathan.
quickly, Jonathan. I was going to mention it right during the day one welcome and opening remarks. So it's 8:45 a.m. on Eastern time on Saturday, and it'd be great to invite all of them. If you go to hamsci.org/hamsci 2026, there's the Zoom registration is now up there. So anyone who wants to sign on for the Zoom virtual workshop, you can do so now, and it's completely free.
Okay. Next on the list, we have, we call on Phil. So Scott Newell in 5TNL. Go ahead.
Hey guys, busy with work, so didn't get to do much radio stuff, but I did get in the mail today one of those USB 3 hubs with per port power control. So I plugged in the 888 and power cycled it, and the green light went off, and I power cycled it back on, and Radio D said 5 seconds with no RX 888 data, restarting. So I was all excited thinking I had a solution, and I don't think it's going to work. So Still got to mess with it, but preliminary results are pretty bad. Back to net.
Okay. Next on the list is Tom, N5EG. Go ahead, Tom.
Oh, good evening, everyone. I have to find the buttons quickly. Still working on the quad receiver and getting the pinout set up between the FPGA and the A to D converters. Trying to make it so it'll work in either a differential or a single-ended mode. So I kind of have to work back and forth between a couple different FPGA loads and the schematic, but still working on it. That's about it. Back to the group.
Okay. And next on the list is Wayne Roth, WA2N. Any comments?
Hello, hopefully you can hear me. Phil
Yes.
invited me briefly to, actually, I'll turn my camera on since I am talking. Phil invited me. We were talking about some changes I'm making to a interface for the RX 888 so that he can use his control program at the same time to be able to change the spectrum and stuff like that. And he mentioned you guys are on here, so it's interesting. And I appreciate all you guys are up to. It would be interesting to go to the conference this weekend, but I'm not going to be able to make that.
Yeah, Wayne's been doing a lot of work on KNIQ Web lately.
Okay.
That's wonderful.
Yes. And Wayne, if you find this interesting, we're here every Monday, same time. So
Okay, cool.
you
Well, I have to
welcome
check it
back
out.
if you find it interesting.
I do. So far, it's been interesting anyway. All right. Anyway, that's it for me.
Okay. Now let's call on Rob Robinette.
Okay. Well, hello everyone. I've just as you've heard from me for almost a year now. I've been working on my the Whisper Demon server system, and it's now in production. So if any of you use Phil Barnard's VK7JJ website, whisper.rocks. Whisper.rocks now once again gets its spot data from the Whisper Daemon 1 server, wd1.whisperdemon.org, which is, I think, well, the previous server was reasonably fast, but this is really lightning fast. It's a 36 active CPUs and a Dell server with a RAID array and lots and 100 gigabytes of RAM. So that server is now fully populated. So if you want to do queries back to 2008 on the Whisper database, that's the place you can go for data. There's also a WD2 backup, fully redundant, and we brought up Michael's WD3 server in Missouri. So we now have geographic redundancy as well as hardware redundancy. So that's been my major focus of interest. We've let's see. That's there was something I've forgotten I was going to talk about. Oh, I gave a talk to the Australian Adelaide Amateur Radio Society on my Friday and their Saturday morning. Had a good dozen of those very technically able and interested hams. They operate the VK5ARG site, which is a really the premier site in the Southern Hemisphere. It's a remote receive station, and it is a Whisper daemon grape site, so it contributes all the WWV and CHU recordings to the server, with the PSW server. Of course, it's very far away, so there's lots of Doppler shift in it. I'm not sure how much we learned from that if there's so many skips between the transmitters and the receivers, but it's a very high quality site and high quality data. They've expressed an interest when I described to them Phil and Scott's work on time of flight. Paul may hear from them. They were interested in maybe adding a time sync injector in front of their receiver. So they're also very interested in seeing if they could add services to record the ionosonts, the many ionosonts that are in their region. And I recall that Phil, you were in some discussions with Andrew Rodland about that. I think it kind of petered away. I think Andrew has been distracted or something. I haven't heard from him much for a while.
I'm sorry, what was the
But
context here? What's this about?
Andrew, KC6G, is it? Or
KC
KG6?
KC2G. K
Yeah.
Yeah, KC2G.
Okay. Anyway, he operates that MUF site that displays.
Prop.kc2g.com. He's actually been very active with me lately. He's now on a Tuesday morning call with me where we're working on this low cost Anason project I have behind me with N4HY and a few other people. So he's rather active.
Well, then maybe I'm just out of the loop. But I think the idea was that when I was aware of it, he and Phil, you can fill us in, Phil. But there was some discussion of how that K9Q radio could have a receive channel that tracked individual ionosonts. That would be, especially now that we have.
Okay, now I remember the discussion.
Yeah.
Yeah,
So-
yeah. That will require kind of a major architectural addition to KNIQ radio, but it is an interesting problem though. I'll work on eventually.
Well, there's a group in Australia that's very interested in it as well. So
Yeah.
so I think it would be a good companion to, if Nathaniel's working on ionosonts, it would be a good companion to an ionoson for us to be able to receive our.
I only know a little about ionosons. Do we have documentation on their signal formats? I mean, are they just CWs, swept CW signals, or are they pulse?
No, there's a variety of different ones, and certain ones we certainly have documentation on, and certain ones there are people who I think would be willing to give us more information about the waveforms. Others are much more sophisticated, and I've talked with them about trying to listen to them before, and it sounded complicated. So there's a variety. The ones that are the easiest to go after are the ones that are just swept CW, and those are known as chirp sounders. And that's the one that Juha Virinen already has. He has the GNU Chirp Sounder 2 program, which is open source that he wrote that will listen to these.
Okay. I mean, I could handle either. I mean, if I know what the waveform is, I can track it. I assume they're all carefully synchronized to GPS time.
Generally, yes.
Yeah. So as long as we have time, I should be able to figure out, where that would be the hardest part.
Another thing that will be interesting at the workshop when you're there, there's going to be a grad student from the Super Darn Lab at Virginia Tech, and she's going to talk, I think, about the waveforms that the Super Darn radars are doing, and there might be some opportunity to listen to the Super Darns and actually talk with them about synchronizing.
Good, because I haven't heard anything about what kind of signal Super Darn puts out. I don't even know what it sounds like.
Yeah, usually it's a multi-pulse sequence. So it's just like hammering with like a Golem ruler sort of multi-pulse. They've got a few different. They have a few different modes that they run. So they're not always running the same thing, but they do have some standard modes. So the grad student's name is Allison Pitzel, and her call sign is N4EON. And she's also she was an officer. She's in the Virginia Tech Ham Radio Club. So she's quite good. I think you'll enjoy talking with her. And she's going to have a talk at the workshop this weekend.
I will be listening.
Yeah, I would love to coordinate more with Super Darn. So if we could figure out how to do that, that would be really slick.
Well, Okay, that's it. It was supposed to be my time, but I'm done. That was the Anasan topic was all I had.
Okay, well, then we're open for general discussion.
I think that's great. So I guess Rob, I guess the first there are a couple things I wanted to talk to you about. So yeah, the first one is the database. So do you think it's feasible to put a local version of the ClickHouse database on the uh PSWS nodes that
Yeah,
just
I seen. I don't know why it would not be. I mean, I ingest all the PSK scrapes and um, all the Whisper and all of the Whisper daemons, all of that, and I can't really see the CPU utilization on my servers. So, uh, so it's extremely CPU and disk IO efficient. So, and
that's
disk
great.
space. So yes, I think so. I've never tried to put it on a smaller, but it doesn't even seem to consume a lot of RAM. So
Yeah.
but I've
Yeah,
never tried it in a.
if you could do that, then what we'll do is I'll have Owen migrate his system away from using the MongoDB, and I'll just have him point to your ClickHouse DB, and then that will give us a very nice architectural advantage of basically of being able to use that on the local system. But then, as I said, if we also want to point it to your central database, then it'll be able to pull from there too.
Yeah, it's they have ClickHouse's built-in backup function and merging. You can merge from one ClickHouse to another as long as they have a IP connection. You can
Okay.
do it, and so you can assemble a large database very easily that consists of contributions from, multiple client sources.
Peaceful.
So I've spent enough time with it now that I'm pretty impressed with it, and I mean, it's just another Linux server, so you have to configure it. That's about it.
Great. Is there anything you need from us? Or do you want to, are you able to just,
I think that it's just that you need to understand that the syntax of interactions, it's SQL.
yeah.
I don't know really know SQL, but it's a SQL like it's select,
Yeah. We
display
can
commands.
we can handle that part. I guess can you take care of just implementing it on a local PSWS node and
Yeah, it's just I
mm,
make it part of the image.
yeah.
I would I would prefer if I could. I Now that I finished the click, I want the server work. I was going to take a little bit of a break. I have a
Hmm.
few for a week or so.
Oh yeah. Yeah,
And then
definitely. You
after
could
that, I'm about to start re-implementing Whisper Daemon Client, and it would
okay.
be a natural time to add the architect. So new software architecture is very much oriented toward having a menu of services that you want to include in your installation, and
Yeah.
one of which could be a ClickHouse database, local database.
That sounds perfect. And then once you get that implemented, then we'll just migrate our system over to use that. And I think that'll clean up a lot of things and you won't have to worry about, us trying to create some other database on the system which could cause issues and it'll
Yeah.
just be a lot more uniform.
Yes. Well, that's it's stability. Software stability is a major goal. So
Yeah.
having
Yeah.
fewer moving parts.
Yeah, this
Yeah.
yep.
In fact, Wayne, who's been with us, thank you for all your work, Wayne. Um, I have not specified any of your many recent commits and Phil's commits in the Whisper Daemon release chain. But like the what I told Nathaniel about ClickHouse, a part of it, I would I was kind of waiting to start work on version 4, at which point I'd start to incorporate new features and new versions of the components elements. But if it's important, if people are missing the work that you and Phil have been doing, I can. It's pretty easy for me to go and just specify a pair of commits, but I didn't see a message about a pair of the functional. These are functional commits. That's what I'm kind of looking for in email. At which point I can go in and edit and just check in the commits that you specify.
Well, I've been adding stuff piecemeal along the way just to make some small improvements. There's nothing grand at this point worth doing. Frankly, a couple of the guys up in Rochester, New York, Jim Lill and his friend Steve Cady, 2OM, have probably because it's winter up there, lost some interest in messing around with the web client. So without testers, it's just as well that we don't, push it everywhere until we know for sure it's good.
Okay, well, I'm happy to do it. I just kind of need an email where you tell. Usually, when Scott was doing these builds, he would just say, "I've tested with these two commits; they work together," and then I just put that in, check it in. So,
And Wayne,
and obviously,
I was going to say, Wayne, I also use web quite heavily, although all the branches can get confusing.
So the lack of complaints has been good lately. I'd like to keep it that way. George, can't think of his call, the guy from Tapper, can pick up stuff pretty well. He's actually a pretty good JavaScript programmer, from what I can tell. I tend to rely on AI quite a bit these days. It knows JavaScript much better than I do, but it doesn't always work. You have to go in and make some fixes. So again, not too much has really changed worth propagating at this point. But we got some stuff coming up. We're trying to integrate the AirSpy R2 and Hydra SDR into Dash Web. That's my short/long-term goal. I picked up one of those receivers at Phil's recommendation, and I've got it running on a Windows machine, and it's actually quite a nice receiver. And pretty soon I'll have the nerve to plug it into a Linux machine and see if I can hook it all up.
Well, I've been running them continuously for years now, at least the AirSpy, monitoring local FM repeaters. I used to run with Raspberry Pis, but Raspberry Pi is just, for compute, you can do better by getting these little NUC machines with Intel or AMD CPUs.
Yeah, it's amazing. I got two of them now. It's just amazing how they've replaced, the 10-year-old desktop that I've got on the floor. I never even use those things other than serving disks anymore. Those little B-Links are so fast.
Yeah, the main problem I have is the USB subsystem. It seems like it's always the case. Limited number of ports, and I'm not quite sure how devices get mapped to controllers, because with the AirSpy and Hydra, which is really a clone of it, they still run in USB 2 mode, which means that you can only have one active device on a bus at a time, and the bus is 480 megabits, and each of those things requires 240. So if you've got like 3 of them on a system, you got to make sure they're on separate controllers.
Oh, okay. So you've actually run multiple AirSpies?
Oh yeah, I have 3 of them running on one NUC, on one of the B-Link boxes.
Oh, cool. Then I should be able to get the RX 888 and that going at the same time with any
Well,
one.
I run my RX 888 on a separate machine.
Ah.
So
I actually have 3 machines running just to keep things somewhat sane. The third one is running a Rig Expert Phobos, which is monitoring airband, because it's wider than the one. It doesn't use TV tuner like the AirSpy and the Hydra do, so it can receive more than 10 megahertz at a time.
Yeah, that would be nice, actually.
And that generates a lot of disk files. There's a lot of activity on the airbands. I'm also decoding ACARs.
I have a question on the RX 888s. I think some people, I've heard on this group, some people have run multiple RX 888s on a computer. Do people still do that?
I've run 3 on a B-Link.
You've run 3 on a B-Link.
Yes.
Okay. And because for the project I'm doing with Gordon W2TTT, I think we might want to run 4. And I happen to have like an extra rather powerful Linux desktop lying
You
around.
want to run 4 RX 888s on one machine?
Yeah, is that reasonable?
I think,
Oh God, you guys
Not
never give up.
it
well.
depends upon the PCI. You need to have individual. I'm pretty sure
It
you have to have
it's a
individual PCI.
multi yeah, it's a multi, it's a Core i9 machine probably with like
It's
8
not the speed of the CPU is the issue.
It's
but
the USB subsystem.
right, but and it has multiple PCI expansion ports, so I could
Yeah.
theoretically put in a bunch of USB 3 cards and it could be okay, right?
yes,
Yeah.
you
Okay.
Now,
can.
limitation on the processing side is not going to be CPU core cycles. I mean, we have an embarrassment of riches nowadays, 16
Right.
core machines that are hard to keep full. The problem is going to be memory bandwidth. Can't actually radio D is very memory intensive.
It's got 120 gigs of RAM.
Well, it's the cache.
That's not
It's
the
the
issue.
speed of the memory. It's not the
Yeah.
size of the memory. It's not that bad. It's the
speed.
bandwidth. Yeah.
Okay.
I'm doing 3 million point FFTs every 20 milliseconds.
Yeah. Well, we have the computer lying around already, so it's not doing anything right now.
I mean,
so
let us know how it works.
Okay.
The issue is there's two issues. One is the PCI, I mean the USB controller, and there are different kinds of many controller cards. You get PCIe controller cards have a single controller with 4 ports on it.
Yeah.
And those may be a problem. When I plug in the 3 888s into the B-Link, they do connect to 3 different controller chips inside, and each controller chip being is attached to the PCIe bus. So the PCIe bus can easily handle these this bandwidth, and there, if you had two triple eights connected to one USB controller, then it has to arbitrate and communicate, between the 2 inputs. So it's if you're going to have contention, you want it on the PCIe bus, on the USB input. But there are, like in the servers I put up last week, I think it's called Highland. I can't remember it, but they make the controllers that are the $19 PCIe controllers, the cheap ones, will have 1 controller chip and 4 ports. And that's not what you want. You want the $120 USB controllers, PCIe controllers, and which have 4 chips on them.
Okay.
So that's one thing. As Phil says, the other side is it's actually not CPU cycles so much as cache memory bandwidth.
Okay.
So Whisper Daemon, I've talked about this at length, but I'll repeat now. Is Whisper Daemon, in order to get multiple 888s to run, or even one 888 to run glitchlessly, absolutely glitchlessly, you really need to put have Radio D, assign it to its own pair of hyper-threaded CPUs that have their own level 1 and level 2 caches. When so configured, okay, then and when there's multiple, when I set up multiple, the 3 inputs, then I assigned 1 888 Radio D for 1 888. I assigned it to cores 0 and 1, a second to cores 2 and 3, and the third to 4 and 5, and it ran just fine. And each of those cores runs at about 50% utilization.
Right.
So and you can see that it's running. You look at what happens. Ideally, when you look at the strip chart of how the CPU activity, when the Whisper Daemon fires up and uses 100% of CPU on the other cores, you should see no change in the CPU utilization of the cores that are running Radio D. And that B-Link will do that, especially well, it needs to be the B-Link with the 16 megabyte cache. The one we specified for Whisper Demon does have that capability. It has a 16 megabyte level 3 cache, eight 4 megabyte level 2s, and eight I think half a megabyte level 1s. So that's that with in that configuration you can run at least three, and maybe it potentially four. I didn't go that far. It's the it depends
What?
what you're processing. I mean, okay,
Yeah.
if you're not doing a lot of processing and just recording these, you might be able to have eight, or eight triple eights, because there's not a
Not
lot
bad.
of
Hmm.
but I don't think four is out of the question. And to the extent I can tell, uh, from Radio D's, from the monitor program, or the control program, under the three input scenario, I never dropped a frame. So
Okay. What if I'm looking at the spec sheet for my computer right now? What would I be? Is
what
it just a
what's
cache?
what's the well, you can run LS CPU. And do you have
I
it? Is it you don't
no,
have it on?
I don't have the computer in front of me. I just have the
Okay.
specification sheet.
What is the processor?
It's an Intel Core i9 10940X.
940.
Yeah,
S is in sugar.
X is an X-ray.
Hold on a
i9
second. Okay, hold on a second. I9. I yeah.
dash 10940 X-ray.
Okay. Hold on, I got to get something to compare it with. Uh, yeah, let's see. What is it? It's yeah, 14 cores.
Mm-hmm.
Oh yeah, that's an excellent. That'll be an excellent performer. Yeah.
Yeah.
Yeah, it's very looks like a very nice
Yeah.
power hungry machine, 165 watt TDP. It's over
Yeah.
10. Here's the comparison. If it just this is kind of where I go first. The definitive way is to go to LSCPU and look at it.
Yeah.
But if you're interested in if your CPU can say, here's your i9.
Okay.
Okay, and if I what I look at is ignore the clock speed is kind of not so
Mm-hmm.
important. The number of physical cores is very important.
Yeah.
uh, because you're by distributing and assigning Radio D's threads
Mm-hmm.
to a hyperthread pair, you exploit the caching.
Yeah.
So a level, and it looks like from what I could tell that the cache sizes are large. I mean,
Mm-hmm.
level two, I mean, I'd have to look at the exact, you need to run LSCPU-E to actually know how the caches are organized. But you can see that the cache sizes, especially the level two caches, are much larger than our reference, the 5825.
Mm-hmm.
So it's you can see the power. It wouldn't be someplace you want a solar power. But if you go down and look at the single thread rating, it's not quite as powerful as the 5825, but there's 14 of the cores. So it's the CPU mark is somewhat useful, but
Mm-hmm.
as a metric. But there are some Intel cores that they have efficiency cores, and uh, that are not really suitable for running Radio D. So you need to make sure that the Linux scheduler doesn't put your uh, Radio D onto an efficiency core, because it's
Mm-hmm.
likely it'll likely, or it doesn't reassign it there because, oh, it's idle. I guess I can put this very busy Radio D FFT on it because nobody's on it. Well, it doesn't have enough, it will be for a bunch of reasons that would be a very poor choice.
Yeah.
But this things look like a very reasonable, a good choice in the Intel family.
Okay. So, as I said, I have this computer lying around not doing anything. And if we can use it, we could potentially use the money that we do have for this project for other things. So,
I think you should try to use it.
all right.
As long as the electricity budget doesn't break your budget.
No, that it's running at the university, and no one's come to me at the university talking to me about that yet. So,
okay.
Hey Rob, I've returned to this CPU affinity stuff that you've been working on, and getting ChatGPT to write some code to basically investigate all the CPUs and how they're paired and so forth. But I still want to tread very carefully here in anything I want to embed inside KNQ Radio because I don't necessarily know every environment I run on. I'm especially concerned about CPUs that are not all the same. And it basically makes recommendations that it's along the lines as you've done. Give the FFT one of its own pairs of CPUs to run on, hyper-threaded pairs, and also hash the channel IDs so that each channel slice tends to run on the same core. That seems like a good idea because when we traced things like migrations, from one core to another, the rate was very high. Apparently, when a task only runs for a couple hundred microseconds, like most of my channel tasks, Linux tends to move them around a lot for some reason. So pinning them to run on the same core that they started on is probably a good idea. I'm going to try that experimentally, see if it makes much of a difference.
Yeah, I've had Chat write a little bash function that went in and figured out how to assign the different
I would if I'm going to do this inside of Radio D, it would be of course C code, and it's already written C code for me. It looks pretty good at basically reading all the sys files and figuring out the processor arrangements. And
no,
the big concern is what happens if I run into a CPU where the cores are not all the same.
Just have a config thing to disable the whole mess. Don't do any of
I tend to be I'm reluctant to rely on config files because there's plenty of opportunities to get them wrong. If I can do something automatically, I much prefer to do it that way.
I would make it a default automatic, but have a way to override it if
but I don't want the automatic to require an override.
Well, I don't know. I mean, you need to then look at because the outliers I've seen in the CPU space are the Intel, some of the Intel processors where they say they're 20 core devices, but then in fact they have 8 efficiency cores that have tiny little caches of each one of its own, and only 6 cores that are hyper-threaded with reasonable size. Well, I could see Whisper jobs, which doesn't make much difference. They can run anywhere, but they're not time sensitive. But if Radio D were to be assigned to an efficiency core, that would be a problem, I think.
Well, it depends on what part of it. I remember Radio D is hundreds of threads.
I understand. If they assigned well, here's the thing though. If your cache access time limited, right? That can and if you and so if you move the lin threads, right? The other major group of threads, if you move them off of the hyperthread pair that is doing FFT and proc, if you move it off of that, then you suddenly have to do these lin threads, which aren't quite so time sensitive. In my understanding, they could slip a little bit.
Well, they run quickly, a couple hundred microseconds.
I understand. I understand. So, but if they're on some efficiency core, that core has to get itself refreshed from the level 3 cache because it doesn't have the data that was created by FFT. You're going to end up you're going to end up with a lot of cache stalls on your LIN threads. So in my experience has been I was going to dedicate the FFT to basically to nothing runs on it except on core 0 but the FFT. And
Right.
then the proc and all the LINs run on the hyperthread pair. And that and in that configuration, that core 1 running the everything else uses just about as much CPU as the FFT. So,
Okay.
and you also another validation is to look at the at BTOP and look at the strip chart. I mean, if you it's really here's a really good example. I happen to be looking at Tom Paratori's. He has an i9. Where's my share? I've lost this window, but he's got an i9 that has a one local. Let's see, we're in Zoom. Has one local 888 and 7 Kiwis. Okay, and he's decoding them all on this i9, and it's busy. It's as busy as I've ever seen an i9. Uh, but you can it's a good example of how to no, that's the wrong one. That's my server. How do I get out of this? I'm sorry, I picked the wrong window. Uh, Here is Whisper Demon. Okay, this is Tom Paratori. He's number 2, number 3, basically number 2 spotter worldwide. He has 7 antennas. He's in Long Island. So he's decoding about 70 channels here. 20 of them are from the local 888. And you can see that in his case, the hyperthread pair is C0 and C10. It's a 20-core machine. It is symmetric. And notice that we've just fired up, WhisperDemon has fired up 70 WhisperD decodes. But WhisperDemon has been confined to all of the other cores. It cannot run on the. And notice how there's no effect on the CPU utilization on Radio D and on C0 and C10. That's the way you want it to look.
Yeah.
Okay. Because if you don't do that, you'll see bumps in these C0 and C1, or if they bounce around, you can't follow them. Of course, if you just didn't do an affinity, you really couldn't follow this behavior. But even if you do this, the other thing I do is I turn down the clock rate of WhisperDemon. I mean, there's enough time here that to finish all of the decodes in well under 2 minutes. So run the other cores. Well, in this case, I think I run the other cores at 2.8 gigahertz or something, somewhat slower. And that means that the radio D cores run faster, so they're more likely to hit the cache and keep their especially level 3 cache entries warm. The ones they want are likely to stay in level 3 cache, more likely. So those
Yeah,
are
level 2 may be a factor also. That's actually a bigger
but they
because they're
share
local, you don't want that's where
well,
you really want to minimize migration.
well, you minimize and well, C0 and C10 share level 2 cache. So if you look at
Yeah.
LSCPU-E, this is how you find it. I don't know if you can all see this because it's probably
Yeah.
small.
Are you leaving one completely untouched? I mean, for the rest of the system,
One
especially to
pair,
handle interrupts.
one pair is dedicated to Radio D. Cores CPU 0 and CPU 10 are being uh, allocated. Only Radio D has access to those.
Oh, all of Radio D runs in one core pair,
Yes, yeah, it's
including
plenty.
FFT. Okay.
Yes, yeah, FFT. If you look at, I don't think sometimes I will actually assign the FFT, but it's likely that if you, I can't control.
That actually kind of makes some sense because I've noticed that most Radio Ds don't really need more than 2 cores on average, usually about a core
They
and a half.
don't. They don't. They're not,
Yeah.
if they need more than two, if they need more than a hyperthread pair, this is an application that really benefits from hyperthreading. You
Yeah,
and because core 0 here in this case, core 0 and 10, they share the level 2 cache. So FFT creates, is spitting out this the frequency bin data, and it's going into the level 2 cache where C10. I'm sorry. Well, the proc. I'm sorry. The proc spits out the data into the level 2 cache where the FFT running in core 0 can immediately pick it up. It doesn't even have to
right,
go down to level 3.
right.
So by assigning them to a pair, a hyperthread pair, you maximize the utilization,
Yeah,
access
yeah.
time
That,
to
that makes
the.
sense, except, my working sets are bigger than even the largest cache. Look at number of points that I have. Each one is a float, 32-bit float complex. I really wonder just how much cache pressure there is, even if you're not
Uh, well, I've seen it. I mean,
collaborating.
I mean, you can see here all the other cores are waking up and they're going
Yeah,
through the whisper decodes. Now those are, they don't require a lot of data. Those are the outputs of the lin thread, so that each one of those
they're
is looking
probably
at a.
better behaved. I mean, they take a lot of CPU, but they're probably better behaved in cache, utilization.
Yes, the cache sizes. I mean, they probably get all after they get their data. They probably are working entirely in the level one and at most level
That's
two
right.
cache.
Right.
So, but if you're not careful and you let Radio D and FFT go anywhere they want, uh, you will end up with drop frames. You'll hear
Yeah.
it. You'll hear
As
glitches
as a
in
way of
WWB.
pushing
The-
out, crowding out other people's data from their caches.
yeah.
Um, What I don't know, I mean, there's a lot of unknown here, a lot of variation in what FFTW does with its wisdom. I mean, much of what it's trying when it generates wisdom is various memory striping patterns. And so I don't actually know what's left in the cache when an FFT is done, if it's so large that it can't all be kept in the cache, which is, I think, usually the case.
Yeah, I don't. Yeah, I don't. All I can tell you is that this allocation of your jobs works beautifully, and
Well, it's simple enough to try. I mean, just hardwire all radio D to one hyper-threaded pair and see what happens.
that
I can
yeah.
do
But
that easily enough here.
but you need at the same time to exclude all the everybody else from those.
Yeah,
That's
yeah,
that's the challenge, okay?
yeah,
Because Linux will just slap a process into your
right,
FFT
right.
core, yeah, because oh, your FFT core is only 40% busy. I'm going to stick a Whispery job there to make sure that it's that CPU get utilized, and it completely trashes the cache.
Yeah.
So this so now I have not gone to the extent of excluding all other Linux programs from Core 0 and Core 1,
You
Core 10.
probably should, because for one thing, there's a very high interrupt rate coming from the USB subsystem, and those have to be handled by something.
Well, that's
Um,
a well that would be the thing is that those are if kernel assignment of course has to be done in grub. So if you're going to do that, you're going to have to go in and modify the user's grub
yeah,
conf file. And
yeah,
I I stay that to me is danger. I don't want to touch somebody's grub configure.
yeah.
So uh, to me, in all of the installations, and I'm not talking just about our B-Link installations, because I have people running on Pies. I've this understanding of this came from trying to figure out how to use the OPI, the eight CPU non-hyper-threaded. So it's 8 individual cores in an OPI, ARM 76s in the OPI 5. And when we first tried it, there were all kinds of glitches. We turned to WWV and it
I
was
remember
glitching.
that. Yeah,
Remember that? And we all thought,
yeah.
oh, there's something wrong with the OS. You need a real-time OS. No, you didn't. No, and when I went
Probably
back to
help.
when maybe but but the solution was assign use CPU affinity. And once I put in CPU affinity, that the OPI works just fine as and there's no glitching, no background glitches in WWV audio or other audio.
Good. Yeah. On a
Not that I
related
use the
topic,
OPI. Right?
well, I was going to say on a related topic, the reason I started looking at this again is I've been getting email from Nathan Higgins. He's the guy in Scotland who does Uber SDR
Yeah.
based on KNIQ radio. And he sent me some patches to solve what he claimed was a thundering herd problem. And I dug into this, and I think we come to the agreement that actually there isn't a thundering herd problem. I mean, that was fixed in the Linux kernel some time ago. Thundering herd refers to what happens when you wake up a whole bunch of threads at once, and they all fight over a resource, and only one of them gets it, and the rest of them go back to sleep. But you can see how that could happen in POSIX threads when you wait on a condition variable. There's always an associated mutex, and when you do the wait, you implicitly release the mutex, and then when you get the condition, you grab it again. But it turns out this is such a common operation that Linux has fixed this so that you don't actually have to wake up all these processes, only for most of them to go back to sleep. So we kind of come to an agreement that the problem doesn't actually exist. But at the same time, when I was getting ChatGPT to look at some of my trace logs, it did comment that my migration rate was unusually high, and lowering that would probably help. And that's basically what you've been saying.
Mm-hmm.
Because every time that happens, it requires
yeah.
a cache reload.
I think, but as I say, this is as far as I needed to go in order to get reliable operation.
But what I don't really understand is why the Linux kernel isn't already doing some of this. I mean, shouldn't it want to prefer the same core? And I asked that question. It gave me an answer saying it does, but it doesn't really know as much about your program as you do. I have to go back and reread that to really understand why you have to tweak this manually. Because this is the kind of thing an operating system really ought to do for you.
Yeah, except look at, how is the kernel going to know that your proc missed a USB packet?
Well,
so if you're the kernel looking at that window right now that I'm sharing with you in the upper right-hand corner, wouldn't it say, geez, C0 and C10 have empty cycles, let's put something on it?
Yeah, I think that's what it's doing. It sees the core go empty. It's got something to run. Instead of waiting, it throws it onto that core and it upsets its cache. So I think that's what's happening.
I don't know. What's the reschedule rate on Linux? I thought it was every 100 milliseconds or something.
Oh no, well, not a real-time kernel. I don't think there is one.
Okay.
And when I'm using real-time FIFO, the real-time FIFO option. What that means is that one of my threads gets scheduled. It gets scheduled with some absolute priority. They're all the same. I could change them, but all the receiver threads run at the same priority. And when one gets dispatched, it runs until it blocks. It's never preempted. And since they run for such a short time anyway, there didn't seem to be any point in allowing it to be preempted. But typically they run based on CPU utilization only a couple hundred microseconds before they block again. That's how long it takes to run the inverse FFT and do all the processing the channel requires. But then there's lots of them.
But if you have something like this pathological case where Whisper Daemon fires up and runs 100%, then I think that's the that's the source of these problems for the kernel scheduler. Is it looks at those, there's, hey, wait a second, I've got 20 cores and there's 2 of them that aren't fully utilized.
Right. Yeah, right. I think what the kernel's doing is it's always trying to keep your cores busy, even if that slows you down. It doesn't know that that's the case.
It doesn't know. Now notice there's a little bump there on the C10. There was a small bump at C. There might have been something else that run. That got in and ran on the C0, C10, a Linux or something. A utility.
I'm not used to this page, so I have to study.
Oh, this top page, this BTOP is really the
I know. I see you running it a lot. Often I just run top, but
this is top is I also frequently run top at the same time. It gives you a different view.
Yeah.
It's just a different way of, if you want to, you taught me this, here's top view down below,
Yeah.
and you can see FFT as they're running it.
That's what I usually use it for, is to see how much real time the FFT is using.
Well, you see, it's hard to see. You see, once all of the other start running, they're running at higher CPU percentages.
Yeah.
So,
Yeah. You
so
got
it's
a
hard.
little idle time, but okay, now it's oh, is it just
So,
a
but this that group of the top line of BTOP, the overall strip chart and the individual core strip charts, I think are the incredibly valuable insights into optimizing your
yeah.
systems.
Now
And
that sliding window in the upper left-hand corner, that's only looking at a few cores, right?
the big window on the top strip chart is the aggregate of busyness. So you'll see it never hits 100%. Okay, it's never going to
Yeah.
100%. It's going, if you look in the upper right, it's running at 95%. Okay, right now. And that's because
The red's kind of hard to read. Let me brighten up my screen
you
here.
want me to I can make these larger if you want.
Yeah, that might actually help. Let's see, how do
Okay, here, let me make this
maximize my screen somehow?
no, see, let me make that large, and I'll
Yeah, that
make
helped. Yeah, there we go.
here,
Yeah.
and I can make the
Okay, so the graph on the moving chart that's total CPU utilization,
total. Yeah, the big one
which
is
doesn't help
total.
much, right? I mean,
Yeah,
that doesn't really tell me.
it doesn't help you much. No, it's the ones over on the right. Look at those individual cores.
Yeah,
You see that the big bar next to CPU tells you that it's 96% busy, aggregate, the sum of
yeah, yeah,
everything. Okay.
yeah.
So, and by the way, there's the core temperatures are sitting over there on the
Yeah,
right.
core temperatures, that might be an interesting way to look at average utilization.
And you can see that all the other cores, you can see the cores one
Okay,
through,
and now I can see, okay, each one is an activity bar.
yeah,
Okay, I understand.
yeah.
Yeah,
There's individual strip charts in the upper right-hand corner.
yeah. And you got 20 cores.
So,
So C0 and C10 are paired, C1 and C11 and so forth.
yes, they are.
Yeah, that doesn't seem to be standard. So the code that I had ChatGPT write for me does
you can, yeah,
parse all that stuff.
there are kernel calls that will tell you the hyperthread pair. You give it there's a kernel, it's actually, one of the proc registers
Yeah,
where
it's not a kernel call, it's a proc file system entry. Right. And
yeah,
that the code I have that it wrote for me does that.
yeah. So
It does all the tedious stuff of parsing the text in those files.
yeah, that's what I got that from chat. So
Yeah.
but so you can see, well, you see Tom runs at C3000. So that's one of the
Yeah, I
reasons
see now
why.
C0 and C10 are low utilization, even though you're running your decodes, because
Yes.
it's right after an even minute. Yeah, so you're
Yeah.
decoding.
You see, they don't have any of the 100% utilization on the other cores does not affect
Right.
the C0, C10.
Right. So it's not upsetting their level 1 and 2 caches.
That's right. So so this is this is this is a key insight that
I
I
also
got.
don't know about cache fill strategies. When a CPU wants something, does it load it in all three levels, or can it bypass level 3?
There are apparently different. Now, this is the edge of my understanding. There are different cache refresh cache strategies, and you can actually choose the different ones. The cache manager subsystem of a CPU, I think, they frequently offer several management strategies. I don't. Did not investigate that.
Yeah,
I
because I
did.
mean your whisper daemon decoders, although they use a lot of CPU, probably do not use a lot of memory or cache at any one time.
That's right.
And so when they pull their data in to run, they don't really need to go through the level 3 cache.
That,
They can probably do everything at level 2 and then not disturb the data that you want to be there and keep them
yeah.
for a long time in level 3.
Yes, that's right. That was my inference. I can't, this could you see there was a little glitch scrolling off the side there where there was something that on
Something
C0 and
fired up.
C1. It was just, yeah, something fired up while they were running. I didn't notice it, but yeah, I don't exclude everything from
Okay.
C0,
So the
C10.
decode cycle. Okay, everything went to 100%
Yeah, we're
almost.
yeah.
Yeah.
So this processor is just
Yeah.
about as
Yeah. The only
powerful
thing you
as a
might do,
B-Link.
the only thing you might do is reserve another core pair for the opera for some everything else, the operating system, because you are
Well,
servicing a very high interrupt rate.
well, the question is, how do you get those as I said, the problem with trying to do that is that in order to, I mean, the interrupt servicing happens inside the kernel,
Right.
and so you can't just change a line in the system service file. You have to go in and change grub,
Right.
and that would be my last resort. Is
Well, I
to
think I think what it was suggesting is basically you just mask off in all of your programs, you mask off one CPU pair so it doesn't get used by any of your stuff. Um,
Yeah.
and then the operating
Well,
system will probably pick it to run its own stuff.
yeah. Well, I mean, I do that, but I also assign you to a pair your code.
Yeah.
I mean, I was gonna.
I didn't notice what happened to your temperatures. They must have gone up every time you're running.
This processor has a pretty good active, I think,
You can
thermal.
see a spread. You can see a spread.
Yeah, there's a spread. There's a spread between the cores.
Yeah.
Well,
Okay, we're
and
coming up at another even minute. Let's see what happens to
so
the
yeah,
temperatures of the other
yeah,
cores.
yeah. I run the see. I'd have to. I run the cores. Your cores. I run. I think a little faster than I run all the other cores.
There we go. Okay. See, already, I mean, immediately they started climbing up.
Yeah. So there they go. They temperatures will climb, but this is six. This is. I mean, before I get in here, when Tom first gave me access to it, without CPU affinity or processor speed assignments, this CPU was hitting 100C every 2 minutes.
Uh, that made a difference,
100C.
didn't it? Yeah, that made a difference.
Okay. So I could cool